This is the Atari ST, and it could use some TLC ASAP. I'm Matt D'Amico, and welcome to episode 37 of Retro Bits. Hey all, welcome back. It's been a while since we've done a repair and restoration, and the project queue isn't getting any shorter. This Atari ST has been waiting the longest, so today we'll take a first look at the system, give it a once-over, and fix anything that jumps out. Sound good? Alright, let's get started. The Atari 520 ST was first released in the spring of 1985 at a cost of $800 with a monochrome monitor, or around $2,000 in today's currency. The system featured the Motorola 68000 processor, from which it derives its name, S for the 16-bit data bus and T for the 32-bit address bus. At the time of its debut, the system was priced well under competing products from IBM, Apple, and Commodore, yet offered a competitive set of specifications. Now myself, I had never even seen an Atari ST in the flesh until I picked this one up on eBay for around $100 in fair condition with no software or mouse. So while I never experienced the system back in the day, I vividly remember drooling over the tiny screenshots of ST games in various catalogs, such as the phone book-sized Christmas mailer from Sears. Perhaps my memory is faulty though, as I've thus far been unsuccessful in verifying that Sears ever carried software for the system. Perhaps it was competitor JCPenney or Toys R Us instead. Well, for the sake of the narrative, let's go with it. In an interesting twist of fate, the ST came about as a pet project of former Commodore boss Jack Tramiel, who had purchased Atari's console and computer business from Warner Communications in 1984. Jack brought a number of ex-Commodore engineers along with him, including Shiraz Shivji, one of the lead designers of the C64. At the same time, former Atari engineers were creating what would become the Commodore Amiga. But that is another story, and shall be told at another time.
A big name in high tech is back in the news, and for a change, the news is good.
We're back and better than ever. The new Atari has risen like a phoenix from the ashes to emerge as a bold, innovative competitor in the high-tech worlds of both personal computers and video games. When Jack Tramiel and team took over the company in the summer of 1984, the challenge was immense, but so was our determination. And the results have been nothing short of amazing.
This example is a 1040 STF, a model that came out a year later in 1986 and featured a full megabyte of RAM. Due to a price drop, it garnered the distinction of being the first sub-$1,000 machine to be so equipped. The F in the name signifies that it has a built-in double-sided floppy drive, and the absence of an M indicates there's no onboard RF modulator. Earlier non-F models made use of single-sided external drives instead. The ST was able to natively read DOS-formatted disks from the IBM PC, but the opposite wasn't true. Around the back, we find a serial modem port, printer port, and an AXI hard drive connector, or the Atari Computer System Interface. This proprietary bus is similar to SCSI and allows for up to 8 attached devices with speeds of up to 1 megabyte per second using DMA. Moving along, there are connectors for floppy, monitor, and an internal power supply, another change from earlier models. The ST is capable of RGB output at a resolution of 320 by 200 pixels with 16 colors from a palette of 512, or 640 by 200 with 4 colors. It also supports a high-res mode of 640 by 400 when paired with Atari's 35 kHz monochrome display. On the left side is the ST's party piece, factory-equipped MIDI. Because of this inclusion, many of these machines found their calling in the music industry as sequencers and audio workstations. Tools such as Cubase got their start on the ST and remain popular to this day. A cartridge port is also available, and a variety of expansions took advantage of it over the years. And last but not least are the system's mouse and joystick ports. Located under the keyboard in the STF model, if you've heard one thing about the Atari, it's this. When the machine is connected in place, accessing the ports is extremely challenging. You can't see what you're doing, there's barely any clearance, the ports are upside down, I could go on. Even if you succeed in plugging something in, the cord ends up pointing straight out the front. Everything else about this machine makes sense, but for this baffling design decision. As the machine didn't come with a mouse, I had to find one separately. They're pretty few and far between here in the States, and eBay prices are well north of crazy, often $70 or more. Way back in episode 20, I picked up this example from an Ami-based seller in Istanbul for a reasonable €22, and it even included a spare top cover. It's pretty filthy and has yellowed much more than my ST, so the plan is to give it a good cleaning and a little Retrobright treatment. If you recall in that episode, I mentioned that the mouse seemed to work okay, but it didn't want to track in the up direction, so I'll use this opportunity to clean and lubricate the internal mechanism as well. Do you hear that? Sounds like it's time for a nature break. It's that time again, folks. Once every 17 years in the mid-Atlantic states, trillions of brood-X cicadas emerge from underground where they've been feeding on tree roots. The nymphs tunnel out of the ground, climb the nearest object, shed their skins, and take to the skies. For the next month, the trees are filled with the songs of the males, who produce the loudest sound in the entire insect world. The racket is deafening, even ending up in YouTube videos that were filmed indoors. There are so many, they outnumber the predators that feast on the giant, slow-moving bugs. After mating, the cicadas drop to the ground and fertilize the trees that gave life to them. Their tiny offspring tunnel back into the ground and won't be seen again for another 17 years. Truly a spectacle of nature. And we're back. When I first picked up the machine, I needed a way to hook it up to my 1084S monitor, so this happened. Later, I standardized all my systems on RGB over SCART, as discussed in episode 33. The ST's 13-pin DIN port carries 15 kHz RGB with horizontal and vertical sync signals, as well as the system's audio output. It also has pins for 35.7 kHz monochrome video. The port may carry composite sync, general purpose output, audio in, composite video, and or 12 volts depending on whether an RF modulator is present or the system is an enhanced STE model. When I first hooked up the system and booted it, the video output would jump side to side every time the disk was accessed. I figured the first thing to try would be to recap the power supply. Of course, when I hooked up the machine to demonstrate the problem for this video, it was completely fine. Go figure. Anyway, I've got the replacement parts, and I know what I saw was real, unlike the Sears thing, so let's get to tearing this machine down. To remove the top cover, there are 3 screws on the front, 4 on the back, with one hidden under a service sticker that looks to be long gone. Be careful when you lift the top off, as the drive eject button can snag and break the thin plastic surround. Next, we have to remove the power supply and drive cages, along with the floppy drive itself, in order to extricate the main board from the lower case and RF shield. There are a ton of screws as well as metal tabs that need to be straightened out, so it's a good idea to keep track of where each part came from. This broken standoff wasn't the only surprise I found inside the case. I'll glue it back together before reassembly. Things are looking pretty good in here, just a little dusty after 35 years. Another piece of broken plastic. That makes the 5th I've found so far. I'm going to give the case plastics and keyboard a good cleaning, but I'm not going to Retrobright the Atari itself. There is yellowing, but it's not that bad, and I don't want to risk any streaking. This machine has lived a hard life in a public school computer lab, so we're not shooting for museum quality restoration here. Anyway, it's time for a cleaning montage, so let's cue the music. So while we're in here, let's take a quick look at the system board. Starting with the heart of the machine, the Motorola 68000 here is clocked to 8 MHz, 11% faster than the machine's closest competitor, the Amiga. Next, we have 1 MB of memory, distributed across 32 separate RAM chips. Under the RF shield, we'd find the shifter video display chip. TOS, the operating system ROMs, are located here. Early machines had up to 6 chips, but this later model only uses 2 for its 192 kilobyte desktop environment. The last thing of interest is the Yamaha YM2149 sound chip that we'll give a listen to in a bit. With the bottom case dry, I'll repair the first couple of broken plastic parts with superglue. I'm not sure if these machines are especially brittle in their old age, or if this example was just poorly treated in its previous life. It wouldn't hurt to exercise caution when you handle one, just to be on the safe side. I didn't even notice this tab was broken off until I heard it get sucked up by the vacuum cleaner. I had to go rooting through the canister to find what I thought was a misplaced screw, but it turned out to be this piece instead. Okay, while the mouse is outside cooking and the keys are drying, let's tackle this power supply. It's hard to tell from the photo, but one of the caps is starting to bulge slightly. At least there's no sign of leakage. As always, I've ordered the caps from console5.com as I've had good experiences with them in the past, and they have kits for all types of systems, including the ST. New for this episode, I've retired my trusty old Edson Soldapult in favor of something a bit more high-tech. I haven't quite got the technique down yet, but even in my inexperienced hands, this Heiko vacuum desoldering gun is like easy mode. I don't know why I didn't do this sooner. As always, I like to keep a checklist as I go and use a Sharpie to mark each cap that's been replaced, so I'll know the next time I open this up years from now. And there we go! You may have noticed one cap I didn't replace. I ordered my kit over a year ago and there was an error in the bill of materials. When I got in touch with the vendor, he shipped me a replacement part right away, which I was able to install before reassembling the machine. So big thanks to Luke at Console 5 for his excellent customer service. The next issue to look at is the floppy drive. Prior to disassembling the machine, I noticed that the disk would sometimes get stuck and not eject properly. I really don't think the button should be this loose. It seems to be working okay at the moment, but it has priors. Since the drive is already out of the system, let's open it up and see if there's anything obvious we can find. It looks like there are 3 screws, but only one is required to remove the outer case. When I opened up the drive, this little T-shaped part fell out. It looks like it broke off the eject button and is normally supposed to hold it in place. I can't believe they'd rely on 1mm of plastic for that job, but here we are. Superglue to the rescue, once again. To put the button back in its proper place, the front faceplate needs to come off. This is accomplished by pressing up to release the snaps on either side. Once that's done, the button fits into its home by rotating it 90 degrees. Once it's held in place by the front plate, it won't come back out until the plastic breaks again, which it probably will being so thin. It looks like they redesigned this in later models, as they had much larger eject buttons. Hey look, more broken plastic. I should have invested in the makers of Gorilla Glue before starting this project. Since I'm in here anyway, I might as well clean the read-write heads with some isopropyl alcohol. The drive was already working fine, but like I mentioned, the machine led a hard life in a computer lab, so it's probably due. With the drive sorted, we'll need some software. I don't have a modern storage solution for this Atari, so that means creating a disk from an old PC. This Windows XP machine has a suitable floppy drive for the task. As an added bonus, it's a 5150. The software I'm using here is called FlowImage, and it can write Atari backups in ST, STT, or MSA format to disk, and vice versa. Like most tools of this type, it requires a real floppy drive interface, so it won't work with an external USB device. Alright, time to check and see how the mouse is getting on. I think that'll do. Let me get the parts out of the bath and rinsed off. While the plastic parts are drying, let's turn our attention to the trigger wheel mechanism. No wonder the mouse was tracking poorly. It doesn't look like this thing has ever been cleaned. Okay, that's looking a lot better. Since I'm already in here, I'll clean the sensors just in case there's any dust or debris that got in there. And last but not least, more broken plastic and more superglue. Reassembly time, and I decided to put the better of the two top covers on and keep the other as a spare. However, when I went to close everything up and put the screws back in, I found that while they look similar, they are clearly two different designs and are not compatible without modification. Given that, I'll have to use the original part instead. So, how did we do? Well, here's the before, and here's the after. I'm gonna call that a win. Alright, here's the moment of truth. Everything's as fixed as it's going to get today, so let's hope it all works. Well, that's promising. The power supply seems good and the drive is working as well. Yes, with the ST, the entire OS runs from ROM, even without a floppy. However, if there's no disk in the drive, this machine will sit with a blank screen for 50, count them, 50 seconds, before it gives up and boots to the GEM desktop. The mouse action is much improved from before as well. I'm really pleased with how this all came out. The GEM desktop itself has a pretty limited set of features. This is an original machine with original ROMs, so later versions may well have more to them. Coming from an Amiga, I can't help but draw comparisons. There's no command line shell that I can find, and this isn't a true multitasking operating system. The UI works well enough though, and like the Amiga, I'm sure things get better with a hard drive, additional software, and customization. Changes you make to settings such as resolution or color aren't stored in non-volatile memory, so they're unique to each individual floppy, something that can be both useful and annoying in equal measure. I don't have the original discs that came with the system, so I'm not sure what was included. I was able to find a copy of the English language disc for this model though. It has a basic interpreter and a small demo, but that's about it. Even Amiga Workbench 1.3 had a lot more content on the disc than this does, but again, I may be missing out on some bundled software here. The basic interpreter included on the language disk is one of the most interesting that I've seen from this era. Split into multiple windows for entry, output, and code listing, it further invokes a visual editor in a fourth window. Pretty neat, plus it has a handy toolbar, but all the windows do compete for space on the 240p display. Okay, it's finally time to take a look at a few of the games and demos available on the ST, of which there are many to choose from, almost 2,500 in fact. The first thing that jumps out at me is the sound. The Yamaha YM2149 in the system features 3 square tone generators and 1 noise generator. Sound familiar? The chip was originally designed by General Instrument way back in 1978 and was used in many earlier systems including the Vectrex, Intellivision, and ZX Spectrum. So what's it doing here in a next-gen system? Well, Atari had been developing a more advanced sound chip known as the AMI, but for a variety of reasons the project never made it to mass production. They had the old Pokey chip from their 8-bit lineup, but there were a number of reasons why it would have been infeasible to use it with the faster 16-bit architecture. In the end, the YM was inexpensive, available, and could easily interface with the system. But it's not all bad news. In the right hands, the YM can muster a surprisingly good rendition given its age and limitations. Ditto for the graphics. While the ST shifter chip lacks many of the features of the Amiga, such as hardware sprites, blitter, or copper, there were plenty of titles to choose from that offered high-quality gameplay that made the best of what was available. But it wasn't all good news either. For every decent game on the platform, there were any number of poor arcade conversions, such as this one, which is basically unplayable. In some cases, the hardware limitations were just too great to overcome, and in others, proper care just wasn't taken to produce a quality product, as we saw in the Outrun comparison back in episode 19. This in particular feels like nothing more than a cash grab. So it should be no small surprise that once the demo scene got their hands on the hardware, the limits were pushed well beyond their original designs. On paper, the YM chip isn't much better than what's in the TI-99/4A or the VIC-20, so it's all the more impressive that it could be made to play back multiple channels of digitally sampled audio and still have enough CPU cycles left to render scenes in 3D. This, by the way, was one of the areas the ST had a slight advantage over the Amiga due to its faster clock speed and the fact that neither system had dedicated 3D graphics hardware. One thing to bear in mind is that the machine's strengths weren't really as a game system. I've used these games in demos as they do a good job of approximating a system's capabilities. But with its high-resolution monochrome display, the ST found another niche as a business machine and gave them much higher-priced Macs and PCs a run for the money. Anyway, nobody wanted to see me demonstrate a word processor or a spreadsheet, right? Wouldn't be proper of me to wrap this bit up without paying tribute to the ST's most unique feature, would it? Since I'm not about to try and compose a ballad for you, you'll have to settle for something a little more pedestrian. So sit back, relax, and enjoy the ease in which the ST cranks out MIDI tunes with the assistance of the evergreen Roland MT32. So, having finally had the chance to use the ST these many years later, does it live up to those drool-inducing screenshots from the Sears catalog? Well, I'm sure 10-year-old me would have thought so. Present-day me knows better though. The Atari is competent, it's functional, it's fine. But in my heart, I know that it's not an Amiga.
Who's going to win the computer war? Stay tuned.
Ultimately, neither Commodore nor Atari were able to replicate the success they had found with their 8-bit systems, and both eventually bowed out as the era of the PC swept in. The ST line came to its conclusion in 1993, having sold just over 2 million units during the course of its 8-year run. So that's it for today. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time.